What you are seeing here is me using a generator I made using my ModuCoils to light an LED. This video will take you on a journey through all the steps it took to get to this point. So stay tuned to see how I built the ModuCoil generator and to see how well it performs. Welcome to the final installment of the ModuCoil project. For the past 2 to 3 months, I have been attempting to create a fully 3D printed generator that uses modular printed coils that can actually generate a usable amount of power. It's taken many steps to get to this point, and it all started back in September when I uploaded the first video of me showcasing the V1 of the ModuCoil. Since then, I've improved it and made a V2, which has a higher wire capacity. I've made a rotor that makes use of a Halbach array of magnets to vastly improve efficiency by placing the magnets so that most of the magnetic fields are redirected outward. And I've designed and built a coil winder to make it easier and quicker to wind ModuCoils. This time, I'm finally going to be building and testing the generator. I will show each part of the process, including assembling the different parts, and then, at the end, we'll eventually get to some testing. Let's get building and testing the ModuCoil generator. The first step in building the ModuCoil generator is to, wind the ModuCoils. And to do this, I am using the ModuCoil winder that I showed off in my previous video. The coils I'm using are the V2 version with some modified G-code to make it easier to remove supports. They are printed in green Overture PLA, and I have no problems with using this material. You can use any filament you want, as there aren't really any specific strength requirements. Well, anything except TPU. This is going to take a while, so I'll use some editing magic to speed things along a little. In total, I am winding 6 coils here, each with 500 turns of 0.2mm enamelled copper wire. For a first attempt at a 3D print, the ModuCoil winder actually works pretty well. The only major issue I have been facing is maintaining alignment, but this is easily fixable via adjusting the wire guide. Here you can see me wiggling some magnets across the coil, and as you can see we get a voltage reading, which means this coil works and there are no shorts or open circuits. To terminate the coils, I'm not soldering them because that would make them, not really modular anymore, and the use of solder, especially if this type of design was used on a large scale, would complicate recycling significantly. Instead, I am using crimps to terminate the coils, which I will connect later via some screws and nuts. Once I had wound and terminated all of the ModuCoils, I began inserting the ferromagnetic screws into their holes. However, as you'll see later, this was a mistake. Anyway, it was time to move on to the next step. The next thing we're going to do is build our rotor for our generator. As I shown in a previous video, I'm using a Halbach array for my generator. A Halbach array is a means of redirecting a magnetic field so that it is stronger where it is needed and weaker where it is not. This results in a stronger magnetic penetration at the cost of lower frequency. This is purely experimental, and I may try to make the generator again using a different kind of rotor. But to make the Halbach array, all you need to do is grab 1/2 of your rotor and insert the magnets so that each corresponding magnet repels the previous one. What you should end up with is a few strong large poles on the outside and a few weak ones on the inside facing the shaft. But before you do this, you want to secure the rotor half to the shaft via inserting a square nut to the corresponding hole and screwing down the grip screw. After the rotor half is secured and you've inserted the magnets correctly, it's time to grab the other half of the rotor and press the two halves together until they mate. Your rotor should be firmly together, and you want the rotor to be about an inch away from the bottom bearing. Now that we've assembled our ModuCoils and our Halbach rotor, it's time to combine everything together to create our ModuCoil generator. And the first step in doing this is connecting up all of our ModuCoils. I am choosing to connect them all in series here, which will result in a high resistance, yes, but also a higher voltage than if I was to connect some in series and some in parallel. Here, I am connecting each end of each coil to the start of the next one. And this is to ensure that any current induced travels in the same direction. Anyway, once I had connected them all up, it was time to insert them into the slots on the ModuCoil generator cap. STL in the description. After inserting the ModuCoils into their respective slots, it was time to secure them by taking a second cap and pairing it with the first one, making sure that the ModuCoils fit snugly into both the top and bottom slots. 2 bolts were used to secure the 2 halves of the generator together. Except there was one problem I ran into. You see, previously I thought that adding some ferromagnetic screws into the coils would help induction. However, what this also meant was that the coils themselves were attracted to the magnets, and in this generator setup, it meant that there was a lot of mechanical resistance that prevented the actual rotor from turning. So I decided to remove the screws in an attempt to save this project. And after going through the tedium of removing all of those screws, the rotor finally spun freely. This shouldn't affect performance so much as we're using a Halbach array, and that should do a good enough job of inducing current throughout the coils. Anyway, now that we had finished building our generator, it was time to move on to some testing. From me just spinning the shaft with my hand, as you can see on the multimeter, we reach multiple volts and we get up to about 3.5 volts at the highest. This is a significant improvement over the bean cannerator that I made earlier this year, which couldn't even output 100 millivolts. However, I didn't just call it a day and end the test there. I wanted to do another test under sustained rotation, and to do that I printed off a sort of test turbine that I would rotate using a hairdryer in an attempt to simulate wind power. I designed it so that it just secures to the shaft with a grip screw, and from there I could begin testing. I eventually got my blow dryer at an angle where it would start spinning, however it didn't spin very fast, and I think this is in large part due to the crappy wind turbine design and because the turbine is very small. And this is the reason why we only get hundreds of millivolts here rather than multiple volts, as it's a limitation of the actual turbine rather than the generator. Yes, in the future, I'm definitely going to design better turbines. Without a load, I wasn't really able to calculate current output as much, however, you can easily do so via using Ohm's law. The combined resistance of all the coils in series is about 280 ohms, which is pretty big, but it's definitely something that can be improved upon going forward. I think a contributing reason why we're not getting such high voltages from these tests is because they're at low rotation speeds. You see, because I'm using a Halbach array as a rotor, there aren't as many poles, which will result in a lower frequency. I think something like a gear reduction mechanism could increase the rotation speed at the shaft, and so could really test the generator and put it through its paces to see what it can really do. However, there was one final test I wanted to try, and I was very happy with the results. I wanted to see if I could actually power something with my generator. And, spoiler alert, I could. So what I did was I hooked up a red LED to both terminals of my stator and once again began spinning the shaft with my hand, and I was happily surprised to see that the LED started to flicker. This is much more visible in the dark, as you can see here. While this may seem like a small achievement, it's a testament to how far we've come in the past few months. There is still a lot to be improved upon, in design, in optimization, and otherwise, and this is something I will continue working on in the future. However, building and testing this generator and showing it off to you guys, I feel is a nice conclusion to the first ModuCoil project. Well, for me, that's 2023 wrapped up. Things have gone at a bit of slower pace than I would have liked. However, in terms of the channel, I think there have been strides made in terms of things like production quality and so on. Next year I will continue working on the ModuCoil design. However, I also want to be a little bit more creative and ambitious next year, so look forward to that. Anyway, take care, have a lovely Christmas and Happy New Year, and I will see you in 2024. Bye for now.